The work doing a processor totally depends on the use case of it and can therefore not be generalized. What we can indeed generalize are the common configuration options, what we will cover next, followed by discussing connections and controller services. In order to configure a processor, it may not have any running active tasks, and the processor needs to be in a stopped status. Otherwise, you can only view the currently applied configuration. By opening the processor configuration dialog, you basically get confronted with 4 different tabs. The first one is the setting tab, in which you can define quite general information, such as the name of the processor and whether to enable or disable it. Beside these general settings, you can further define the penalty and yield duration of the processor. Both indicate the time interval preventing the processor to run again after any errors have occurred. While the penalty duration concerns errors with the flow file, the yield duration rather concerns system-related problems, such as connection losses. Further, you can define to automatically terminate relationships in this tab. That means any flow file that is routed to that relationship will be removed from the flow and its processing will be considered as complete. This is necessary as in Apache NiFi each relationship defined by the processor must either be connected to a downstream component or said to be automatically terminated. The last configurable option of the settings tab is the bullet-in level. Whenever the processor writes to its log, it also generates a bulletin shown in the user interface. By default, it displays all warning and error level loggings. The next tab, scheduling, is about the way and the time triggering a processor. Firstly, you have basically 2 major time-related scheduling options, timer-driven and cron-driven. While they are quite similar, the timer-driven allows you to run a processor on a defined regular interval, as for example each 10 seconds. The cron-driven scheduling mode runs the processor in a more calendar-like format, such as every day at 12 o'clock for example, or every Saturday. This tab further allows you to control how many threads the processor can use. This typically enables the processor to handle more data in the same amount of time. Of course, these system resources can then not be used by other processors. Keep that in mind by changing this value. The execution setting is used to determine on which nodes the processor will be scheduled to execute. You can either run it on all nodes or only on the primary node. These are the already discussed isolated processors in the previous modules. The Properties tab is the most important tab for the processor's configuration. You cannot find any default properties. They are all processor specific, depending on the use case of each processor. The here defined properties are getting passed on as variables to the processor for doing the actual work. Of course, some processors might have the same or similar properties. Most processors also allow you to define user-defined properties. This gives you more flexibility in handling and processing data flows. For making them even more dynamic, you can further make usage of the Apache NiFi expression language, which we will examine later in this module. A few processors also have an advanced user interface built into them for this. And finally, you also can often refer to other components, such as controller services, which also need to be configured separately. These are kind of global resources usable throughout all processors. And the last tab, comments, simply provides an area for users to include whatever comments are appropriate for this component. Once you have properly configured your processors, and in order to form a data flow, you certainly need to connect them to each other. Usually this looks like getting some data from anywhere, applying some transformations, and putting the data to a final storage. For establishing such connections, each processor in Apache NiFi has a set of predefined relationships that is able to send data to. That means when a processor finishes handling a flow file, it transfers it to one or more of these relationships, depending on the resultant configuration. For example, many processors define just 2 relationships for success and failure. You can also set only one connection and send success flow files as well as failure flow files through this only one connection. It is just important that all predefined relationships are either connected or set to automatically terminate, otherwise the processor status is invalid. After this, let's call it basic configuration, you can further configure the connection to age out flow files once they have reached a certain amount of time being queued in the connection. Or the backpressure thresholds that allow you to specify how full the queue is allowed to become before the source processor is no longer scheduled to run. The prioritizers allow us to control how the data in this queue is ordered. The standard behavior is first in, first out. And the final setting is load balancing. Interesting for clustering, which we have already covered in the last module. Controller services literally only make sense in combination with processors, but generally they are also a very fundamental element for building and managing data flows in Apache NiFi. So far just briefly mentioned throughout this course, These are services which can be shared among components, which allows to configure them only once and use them throughout the data flow. They are running completely isolated and interact above all with processors. You can think of a package of code and configuration parameters that does something in addition to the processor. Apache NiFi offers many pre-built controller services, as well as developing your own custom controller service. One of the most typical examples might be connections to external services, for instance databases or APIs, where the controller service encapsulates the connection parameters. Another example are reporting tasks, sending statistics about NiFi or the Java virtual machine on a regular basis, or to predefine or transform data into certain formats.